Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
And we're still in our terrarium here at
the People Aquarium.
NDC.
It has no roof, so you literally can throw the fish food over the side.
It really is. I feel like a turtle in a terrarium.
Please send pulled pork sandwiches.
Oh, now I'm hungry. Well, anyway, we're here at NDC in Oslo, Norway, and as we have been for the past probably 10 or more years. 14, 15. Jeez,
goes
really?
way back, man.
Wow. You were at the first one. I was at the second one.
Right. I went to when it was at the Telnor Arena, which is actually outside of Oslo.
Yeah.
And then they came into the Spectrum here, downtown.
Yeah. Wow. Cool. So Meg Gotshall is here. We'll be talking to her in just a second, but let's roll the crazy music for Better Know a Framework.
Awesome. All right, friend, what is your framework today?
I am not done talking about the .NET show.
Okay.
Yeah. So I just got done doing a talk, which is also on the .NET show this week, and this is the 29th of September. So that was 4 weeks ago?
Yeah.
Yeah.
3, something like that.
Yeah, 3 weeks ago, right? So basically, I'm creating a new .NET Rocks mobile app.
Cool.
Because God knows we need one.
Do we? I don't even know. I mean, I listen to the show on podcasts.
Yeah.
I think it's called Podcaster, but you know.
Yeah, the podcast
But I'm on the
app.
Android side, right? As opposed to the iPhone side, where it's like just what Apple gives you, and you'll like it. Dang it,
you'll love it.
Yeah.
But for years we've been talking about how we'd like to have some features in a mobile app, such as if you're listening to something, I just want to press a button and that emails me, and gives me a link where I can jump into that point again.
Yeah. Well, or at least I think the number of times I've got an email from someone who said, "Hey, I was listening to one of the shows, but I don't remember which one.
Yeah.
With that guy, but I don't remember his name.
Yeah.
About that technology, but I don't remember what that name is either. Can you send me the links?"
Yeah.
Right.
Yeah.
And so the idea that you could hit a button and it's literally say, "You were listening to this show at this time.
Right.
Here's the show notes."
Right.
So
we could
just
do
save yourself
creepification, sort of keeping track of your listening habits.
Well, I mean, that's our benefit, but the benefit for the listener would be, you have you're often listening where you can't do much, right?
Yeah.
You're in the car or something, like, don't take notes while driving. That's bad.
Yeah.
So the fact that you could just hit a big red button and lo and behold, that'll be waiting for you when you get to the office, I think it's a great idea.
And also share a clip to social media is a feature that we've been talking about. Right.
Go further on all of that.
Yeah. So anyway, I started a series on the .NET show where I'm creating a new .NET Rocks mobile app written in Maui Blazor.
Okay.
So Maui Blazor, or Maui Hybrid, I guess you could call it, is all of the stuff that Maui does cross-platform on Windows, Mac desktop, iOS, and Android devices.
Nice.
Except that you're using Blazor as the UI instead of XAML.
Excellent.
But it's Blazor not in a sandbox. It's Blazor with access to the entire device.
Okay.
Yeah. Which is a new thing, It's
new possibilities. Oh, I can't wait to see it.
Yep. So check that out. It's at the.netshow.com. And by now we should have a couple more episodes up there, getting closer to the feature set that we want. And I'm going to take it on the show all the way to putting it in the App Store. I'm going to go through the whole process in the videos.
Great learning experience. And you've done App Store stuff before. Like, it'd be good to learn what it's like today.
Yeah, that's right.
Especially Android versus Apple stores.
Yep.
All right.
So that's what I got. Know it, learn it, love it. Who's talking to us? Mr. Campbell.
Grabbed a comment off of show 1702, which you did back in August of 2020 with Rob Schieffer. We were talking about building serverless.NET apps on AWS, which coincidentally, we have another AWS show coming out while we were recording this, because we happen to be recording on a Thursday.
Right.
But it was just a conversation about scaling the cloud and the differences and so forth. Rob had great conversation. And one of our regular commenters, our friend Richard Rukima, who's also been on the show, but it's always great for a comment, said this admittedly a couple of years ago, where he said, "I love this discussion, but Azure has this hands down for creating a new paradigm of apps built as platform as a service, which can totally disrupt verticals, which are so ingrained with the server or data center mentality. Azure is a cloud service provider, where AWS is a cloud data center provider."
Right.
And I wonder if AWS is working hard on changing this. Part of the reason we were talking to Isaac, right? But most businesses still rely on IT operations to guide their application deployment needs. And that mindset is going to be difficult to shift with the past 20 years of legacy.
Right.
Once a business understands that applications are built on services, they will never look back. The problem we have today is most, if not all, enterprise applications are built with that server mentality and hence have dependencies on where the application is living.
Yeah.
So while Docker may be a good start, it does not necessarily define where the cluster it has to live in.
Right.
An application can leverage dynamic scaling. It doesn't really have practical boundaries in terms of resource if it's architected well. And managing traffic on Azure and all the data centers it has available. The only issue is not the load, but how much you want to spend.
That's right.
Richard read it more politely. He said the monetization that follows that type of event. But it's really, how much would you like to spend? I like
that. Yeah. How much money have you got?
How much money do you have?
Yeah.
Richard, as always, great comment. Happy to read it on the show. I think it relates to the conversation we're having today. And if you want another copy of Music to Code by, ring me up. Richard at pwop.com, and I'll hook you up with another copy of it. If you'd like a copy of Music Code By, write a comment on the website, .netrocks.com, or on the Facebooks. We publish every show there. And if you comment there and I read in the show, we'll send you a copy of Music Code By.
Yeah, and definitely follow us on Twitter. He's at Rich Campbell. I'm at Carl Franklin. Send us a tweet. And you don't even need the mobile app for that.
No.
You can just tweet us.
Yeah, although it'd be nice to have a tweet button there if you comment on a particular show.
Actually, that would be really
cool.
Put
it in a feature list. I like everything about that.
Share this on social media now.
Yes. Here. Yell at Carl and Richard now.
Yell at Carl and Richard, yeah. We don't have that app button yet, but we will.
Yes.
Okay, let me introduce our guest, Meg Gotshall. She is a technical lead at Fotoware, designing and developing a scalable cloud-native storage and indexing system for digital media. 2 decades of hands-on software development with a focus on API design has nurtured her passion for creating extensible and maintainable code bases. Now a veteran of multiple cloud-native systems, she's learned to also apply these qualities not only to the code, but to the infrastructure itself. Welcome, Meg.
Thank you for having me.
Nice to have you on. So you live in the different clouds then. You're not bound to Azure or AWS or any. What are your favorites?
So I've worked with a couple of the options. I'm not going to say which ones, but right now I'm working on Azure. Yep. So I don't think that I necessarily have a favorite because I think they are all kind of essentially the same thing, just with different packaging.
You can get results. You just have to figure out how each system wants to work.
Yeah.
And I think there's a lot more similarities than there are differences.
Yeah, I can't argue with that. In the end, it's always other people's computers.
Yeah.
Right. It doesn't matter which ones you're using.
But even the PaaS offerings have a lot of overlap, and it's a lot of similarities just under different marketing and under different names.
Yeah.
So I will actually say which ones I've worked on. So I haven't worked on AWS, but...
Oh, really? Are you GCP?
So I started on GCP.
I love it.
And now I have moved to Azure.
Right.
And they are a lot more similar than they are dissimilar.
And I would think they appear on the surface superficially as quite different, except I would think on the Kubernetes side of things, because Kubernetes really started in GCP and then clearly came to Azure.
Again, it's just somebody else's computer.
Yes.
So in terms of...
Does matter. And is that something you've done? Like, are you firmly down the Kubernetes pipeline?
So my first cloud project, we very quickly made the shift over to a Kubernetes deployment because we just needed a little bit more control than we were getting from kind of the managed app systems.
Right.
The system that I'm working on now, we are in the middle of the same transition.
So started with AppService and then realized, we're going to need these Kubernetes controls after all. Orchestration is your friend.
Yeah. So all of the things about, it's easy to deploy a Kubernetes cluster. It's hard to manage it. And the thing is that we actually need the management. So we need...
You go there for the management.
Yes.
Not for the ease of deploying. It's super easy to deploy to an app service. You just can get into trouble. Although that's true of anything.
You just don't have the same fine-grained level of control that we realized that we would actually need. So,
and what is it you see that you need fine-grained control over? Is this particular blocks of services? Like, what is it?
So we have a lot of services, and some of them are little CPU beasts.
Right.
And so we very quickly realized that we needed to move one of those out into a completely separate AppService plan just so that we could give it the resources that it needed.
And scale it the way you needed to scale it, I bet. Right. Do you even go so far as to change the architecture? Like, does it make sense to take that little CPU beast and turn it into serverless? You like my CPU I'm in love with the phrase now. Meg has given me new words today. I'm very happy.
Because of the nature of what it does, it's basically our image processing module. So,
you're with Fotoware, and that's their skill set, right? Is managing media for me.
So it's the component that is doing basically the preview generation for all of the thumbnails and taking these massive, say a 10 meg raw photo and managing to produce something that's actually usable on a website. Oh, right. So,
and then you almost wonder, like, would it be better running with GPU resources rather than CPU resources? Like, if you've got it in its own plan, you have the choice to do that.
We have a lot of choices. And that is the beauty of working in the cloud, is you have too many choices.
Yes.
And that was what I was talking about yesterday, is that really, at the end of the day, you just have to make a choice.
Yeah.
And it doesn't necessarily have to be the right choice. It just needs to be a choice, and then test it and find out
and explore.
If it's actually working.
When you peeled it off and gave it its own, essentially, can to live in, now you have, all right, what do you want to try? Can we use a different plan here, like the bigger CPU resource or bigger memory resources? That seem to make the difference. Like, you get to do all these empirical trials, essentially, till you can find the sort of optimal scenario, not only just from a performance perspective and customer sat, but what is that costing?
So when your friends and family ask you what you do for a living, do you say, my head's in the clouds?
Not very often.
But I mean, that kind of describes what you do. I mean, and it's plural, clouds.
Well, right now it's one cloud.
Yeah.
So I bounce from cloud to cloud. Is that what I do?
There you go.
Hey, you get off. Never mind. We could go on and on. You could go on and on.
On and on and on.
Last time I used GCP, it really, for me, solidified the fact that the docs on the Microsoft side are so good, and everybody else's are not as good. I mean, I had the same sensation with AWS, just the documentation is more challenging to navigate. It was when I did that. What do you think?
I think there's a lot of documentation, and I think a lot of it is really good, but it's a lot to go through, and sometimes on Azure, it can be a little bit difficult to find what you're looking for because it is kind of spread out. So there is a lot of information out there, but it's not always easy to find what you need.
Well, it's also a question of, is it correct, too? Because they keep changing stuff. Like, it's always a race of, how old is this doc? Oh, it's from 3 months ago? It's probably wrong.
We have definitely run into that situation. I kind of wonder if that's what Azure support has as their primary objective, is to fill in the gaps of what has changed since we wrote this documentation.
Yeah, since the documentation was published. Well, and just actually trying to tag that stuff up clearly to say, is this current? Is it not current? Like, can you direct me to the new version, please?
In general, I think the Microsoft docs are laid out nicely. Mm-hmm. Every time that I go there, it's current.
Yeah.
And not only that, but you have the multiple versions of .NET that you can choose on the side. So all the flavors are supported.
Yeah. I think it's tougher on the Azure feature side to sometimes.
Yeah, that's, I get that.
I look at a graphic of, look here for this. And then you look and go, not there.
Yeah.
They've moved that.
I do not envy them the challenge of trying to keep all of that up to date. So I have worked in my past life as an API developer and been responsible for writing the documentation for how things work and how you're supposed to use things and giving examples of best practices. And it is not an easy task.
Yeah, it's a living set of docs that need to be changed as often as the code is changed, really. And arguably, you're always trying to make them better, too.
And now, as often as the infrastructure changes, because underneath all of those Azure features, they have their own infrastructure that they need to support, which they're changing.
So they're shifting as well. I think it's awfully easy for folks to think in terms of scaling as, it's just a knob in Azure. I turn this knob up and I'm good.
Sometimes you don't even have to turn the knob.
Yeah, sometimes it does just work.
If you pay for it.
Yeah.
How much money have you got?
Yeah, how much money? Yeah. Well, and it's like, you've mentioned this too, right? There's the profiling engine that goes, you really should have 2 instances of this app service.
Oh, you know what? I'm going to talk about that on the live show.
that
we do today.
Yeah.
Yeah, I've been very
But I don't know that
impressed.
I've ever had it suggest to say you should peel this service out and put it in its own service. Like that seems like a different tier of recommendation.
Is that like the GitHub Copilot of
Of
cloud
Azure
scaling?
infrastructure. Yeah. You get that smart. It looks like you need your app re-architected. Can I help you with that?
Ooh, I'm having Clippy flashbacks now.
I know, right?
Well, Clippy seems to be back. They've been smart enough not to make a paperclip out of it, but there's an awful lot of smart text popping up suggesting the things I should be doing with one app or another.
It's definitely Clippy. When they killed Clippy, I can imagine Clippy saying, "Hey, I see you're digging a grave. Is that a personal grave or a business grave? Would you like some help with that?"
Yeah. Anyway, now we seem to be happy to take those recommendations more often than not now.
It would be useful, though, to actually have a little bit of guidance, especially when there are so many different options.
Yeah.
Because it's kind of, I see you're using event hubs. Maybe you should be using Service Bus instead.
Yes.
And if there was the Azure Paperclip, or I guess, take this advice, Microsoft. It should be a talking cloud, I guess. Now?
There you go. Yes.
So when Cloudy shows up.
Cloudy.
It says, let's talk about your CPU beast.
Yeah.
and make the suggestions. I mean, normally you'd hire a consultant, right, of some kind to say, okay, are we architecting this right? Like, we're having this problem.
Are you calling consultants the human Clippies of the world?
Aren't we, really? Isn't that in the end the job? I mean, how many times have my jobs really been, yeah, that's normal. You're having normal problems. It's okay. Let's go work our way through them and we'll try and make things better.
I can definitely tell you what time it is for $10,000. Can I borrow your watch?
But nobody wants to be told that they're having normal problems because everybody wants the silver bullet.
Everybody's special, right? But no, you're right. It's like, oh, you just missed this red button. You push this button, everything's better. I'll get paid now. Yeah, not that way.
You forgot to turn up the one knob on Azure?
Yeah, turn up the knob.
Turn up the awesome knob.
What is the knob?
Turn down the suck knob. That's how it works.
I'm jumping back to your thread, your CPU beast. Like, what was the process that made you recognize, this is our problem child. We're going to go so far as to peel it out into its own service?
So we have an event-driven architecture, and basically we had to go back and look at where in kind of our event stream the bottleneck was.
Right.
And so we were having what we call event storms, which is that things were coming in, and because there wasn't enough CPU on the app service plan to be able to handle the things that needed to be done.
Right.
We had events that were backing up and not getting processed as fast.
Sitting in a queue.
And then they would get reprocessed because it's not always a single delivery system.
Right.
So then basically we ended up with kind of an exponential issue where those events were coming in, the events weren't getting processed, the events were getting resent because the events hadn't been processed.
So it's actually getting worse.
And then especially in the case of that CPU beast, if you have that event coming in a second time, now you have just made your problem
really
even worse because
it
is backed up because it is consuming the CPU, and now it's going to do it a second time. And basically the entire system would just spin out of control.
So from the customer's perspective, it just meant it stopped working.
Oh, thankfully we found this in testing.
Okay. But it still is, visibly, it's just like, I set this thing off and the preview never showed up.
Nothing shows up.
Yeah.
So no matter what you're doing with the system, it just wasn't handling anything because everything was backed up behind all of this image processing that was chewing through the CPU. And of course, the system is scaling out because it's chewing through CPU and that's what it's designed to do. So you end up with more and more instances just because that one service was
buried,
occupying everything.
Yeah. And most of that service wasn't doing anything because it was it would just run long enough to stick more stuff against the beast and then wait until it timed out too.
So our first experiment was, well, we know that this is where most of the CPU is going. So let's see what happens if we isolate that, run it somewhere else. And we found a couple of other things along the way that had similar problems, but less obvious. But because we were looking for it, we knew what kind of monitoring profile to look for. So,
and what you're describing reminds me of N-tier development back in the day too. It's got nothing to do per se with cloud. It's like, I've got this one set of classes that when they're put to work, it pins these servers to the wall and everything else suffers. So getting them away from everything else, always helped. That it was called N-tier architecture. Go make another tier.
Mm.
So I guess individual services are the new threads.
Yeah.
That's funny.
Well, because we can't make thread consistency across all these devices anymore. Right. So, they're effectively, that's the binding thread.
We have an old joke on .NET Rocks about Outlook, the desktop Outlook. Mm. It's like 60 threads and not one of them for me. What are you doing?
Where did you go?
Yeah. What are you doing?
But yeah, that beast was doing its own kind of internal processing. So, you get no UI effects. You're getting no callbacks. You're getting no messages. It's just busy spinning.
Well, we work on the back end. So, right. The front end was still fine. The front end is also running on its own
right.
Yeah.
So
threads and its own infrastructure. And
so you got the hold music, though, like dee, 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 and it never comes back.
And probably the user, if there had been a user at this point, would have just said, oh, I'll just upload that again.
Yeah.
And add to the problem.
The services aren't adding enough load trying to get through this, so hopefully we can count on the user to add even more. Just hit F5. It'll make things better, I promise.
Yeah.
Yeah, and it's always funny that if you're not looking in the right place, you don't see any problem, right? But then as soon as you open the right log, and you just like, oh my goodness, I don't know why this is working in any way at all. This is grim.
So we have a separate monitoring dashboard that's it's designed for development.
Right.
And it is basically all of the things. So whenever something goes wrong, the first thing is to look at all of the things and figure out which trend is not looking the way we are used to seeing it.
Yeah. Which of those gauges is in the red right now?
It's not always even the red. It's just what's different.
Right.
So we know what the system looks like. We know what all of the curves and all of the spikes that happen in normal operations.
Right.
So look at all of those graphs and see what is out of the ordinary and look at the things that are different.
Do you fire through your own workload just to see it pass across the dashboard?
In what sense?
Like go generate your own preview request of some kind because you'll see it in the dashboard and see if the numbers move in a good way or not?
So usually if it's just a small piece of work, then
it's just
isn't going to be a problem. It's probably not even going to make a blip on the monitoring.
Right.
A slight increase in resource consumption. So most of the time we see these things when we're doing load testing.
Right. When 1,000 people all want a preview of a 10 gig video.
Well, our load scenario is always the Olympics. So during the Olympics, you have a whole bunch of people taking a whole bunch of photos at incredibly small time increments. Right. And all of that is getting uploaded to these big media organizations. So you have gone from a normal news day to an incredibly photojournalistic intensive news day. So we try to simulate that with our load tests just by increasing the throughput, increasing the traffic, and increasing the request rates. So then when we see those numbers grow, we need to see the system grow with it.
Right.
And if we reach the point where the system isn't growing anymore, then it's a matter of figuring out why not.
Well, I'm sure it's growing more, but it's not actually performing more, right? Like you can add more instances, but you're not getting more throughput.
It depends on where the bottleneck is.
Right.
So if you have something in kind of an event-to-event system, then obviously the downstream stuff isn't going to grow more because if the traffic isn't getting to that stage in the processing workflow, then that part isn't going to grow.
Right.
And you're stuck at wherever the smallest point in the pipe is.
Yeah. What's the squeeze in the pipe? So your load test is showing more and more pictures are being pushed up. And you can see that on sort of the front end of the pipeline. And then you're working your way through the various steps. And at some point it falls off because just before that is your current bottleneck.
And the thing is that this is another reason that we kind of isolated the CPU beast is because at the end of the day, it was still processing a little bit downstream because there was a little bit of traffic getting through.
Right.
So, one of those pictures eventually is processed and then the next steps happen. So there is CPU being used by those downstream services. So it's not like it drops off completely.
Right.
So those look like they're doing what they're supposed to be doing, but they're not doing as much as we expect them to be doing.
Nothing's actually broken. It's just not working as expected. Right?
It's out of balance.
Yeah. For the amount of load in the front end of the pipeline, the back end's not showing enough.
And especially, on kind of some of these managed app services, both in Google and in Azure, they're sharing resources. So it's very hard to kind of pick out how much of those shared resources are going to one part of that versus the other.
Right.
And so I think the original idea behind isolating that one was also just to kind of see what it was doing.
Yeah.
So it's been a while since we made the decision, but I don't even think that it was ever intended to be the long-term solution. Yeah, it was mostly just exploration and figuring out what was going on. And once we figured out what was going on, we realized that we had actually, in some sense, fixed the problem through the analysis that we were doing. Right. So let's move that out. Let's see what it's doing on its own. Let's measure it on its own.
Right.
And
then actually adjust it on its own too.
But at the same time, we have now addressed the problem. So, okay, well, let's just stick with this solution because it works.
Yeah.
No, it makes total sense. And to your point, until you have enough visibility, you're not going to be able to do anything about it anyway, right? Like you've got to put that in there. But then it turns out to be, that's the scaling option, is the more encapsulated it is. Because couldn't you have, in theory, just scaled the whole thing?
So that was actually what was happening, was that we were scaling all of the services that were on that app service plan.
Right.
But if that one is consuming all of the resources on that app service plan, then it's just added overhead to bring everything else with it.
Right.
And guys, hold that thought for just a second while we take this break for this very important message.
Hey, this is Carl, and if you haven't heard my new podcast, Security This Week, you're missing out on an extremely serious look at the week's hacks and what they mean to you. Check out this little clip to get a hint of the searing insights you'll get by listening to Security This Week.
If 3 people have a secret and 2 are dead, you can keep the secret. Remember that.
More wisdom from Patrick Hines. Thank you very much.
I think that's a Russian proverb, actually.
Yeah, I know a lot of people who open a bazillion tabs and never actually reboot and just keep it all open.
Who would do that?
I could give names, but
I think I'm guilty of that. Yeah, we should be rebooting every day.
I reboot every day.
Yeah.
Honestly, add that and your cell phone once a week. Those are some strong recommendations.
You should reboot every day and you should shower every day, whether you need it or not.
That's your STW homework, kids.
But if you get to pick one, reboot.
Reboot over shower. Ew. So I plugged in my webcam and it didn't work. So I unplugged it, plugged it in, couldn't get it to work. So I had this other webcam that I bought. It's kind of a no-name webcam, I think it was made in China.
Or Moscow.
And I got it because it was cheap. And I plugged it in, and all of a sudden, I looked like a colorized Ted Turner movie.
It works great.
It looks terrible.
What you'll find is a great feature of that camera is there's no turning it off. So
it's wonderful. It's actually 4K, so you get twice the size of crap. Go to securitythisweek.com or listen however you get your podcasts. You'll thank me later.
And we're back. It's .NET Rocks. I'm Carl Franklin. That's my friend Richard Campbell.
Hey.
And Meg Gotshall is with us, and we're talking cloud, and we're talking Azure. And I think I have to bring up my story because this is exactly what you're talking about. I was recently very impressed with the Azure portal's ability to help me diagnose a performance issue. And this had to do with the .NET Rocks website and other websites that were just hanging. Right. So we are all dependent on this one API, and the API is a read-only API. It's just for serving metadata for our podcast. It's sort of like an RSS feed, but it has more stuff in it. Like we have information about our guests, for example, your photo and bio, and links, and those things just don't exist in RSS. So, basically it wasn't working, and I went to the API and I followed diagnosed the problems. I was really pleasantly surprised because I had never done this, and so I was a little skeptical if it was actually going to help me find this problem or not. But I noticed that the CPU is pegged. So I go to the CPU pig, right, or the hog. What did you call it?
CPU beast.
Beast, yes. You were watching that pig video. That's what made me think of pig. So I go there, and it says, okay, what are the recommendations about how to fix this problem? And one of them said, your app service plan that this is running under is saturated. It's got 15 web apps on it, and we only recommend 7 or 8. And you should definitely break some of these out. Now, you can do it one of two ways. You can scale up your app service plan, or you can create another app service plan and then move it, right? So I opted for option B, because just scaling up something that's already struggling is going to just prolong your suffering. So, and as soon as I did that, I created, and it told me exactly what I have to do. Create a new app service plan, go to this resource, and then change your app service plan, push a button, boom. It's just like that. And I was really, really impressed because, as I said, my expectations were pretty low, just because these kinds of things never seem to have the right prescriptive.
And how would it have made you feel if that advice had been given to you by a little animated cloud?
Yeah. Angry, I think. Yeah. I mean, I can read. It was perfect. It was the greatest experience of Azure fixing a problem and telling me what exactly was wrong and how to fix it.
Yeah. No, it was right on, which is impressive.
Yeah.
So how far away are we from having it be able to tell you which of your apps you should probably move to a different app service plan? I mean, because that would have saved us a lot of time.
No kidding. Yeah, and again, you quickly summarized something I'm sure you spent weeks trying to figure out.
But I mean, the information is there. I mean, you'd have to manually go through all your apps and look at the CPU load and look at, which ones are, so that they could, it's not like they couldn't do it. It could.
Well, it starts with what's the measurement, like what's causing the bottleneck. In this case, it was a CPU base, but it could easily be a network problem. And there's many things that can ultimately manifest as a bottleneck. Memory, right? You're pinning app server. Another case, you might pull it off to another service. It's like all of these things are running just fine on 64 gig instances. But maybe this one particular service is grabbing so much memory, it's wiping everybody else out. Leaving it on its own will help.
Or memory that is client specific, right? Like in Blazor Server, for example, there's like 200K of overhead for every client.
Right.
And so you get to a certain number and you need to either increase the memory or, split it off into multiple servers. So yeah, you're right. There usually isn't, just a magic formula. You have to kind of think a little bit.
I think it's also interesting to consider the difference between what does a service mean to one customer versus a different customer.
Yeah.
Because we have some very, very, they're microservices, but we always make the joke that they're actually nano services because some of them are incredibly small and do very, very little work.
Right.
And so does one of those services count towards our 15 service recommendation versus having something that is doing a lot of work that has a lot of responsibility, that's consuming a lot of resources. Not all services are created equal.
Yeah, that's true.
But also, like the particular scenario you've described is really an interesting one because it can't be just made a simple piece of code. It's complicated code, a sophisticated language with a runtime. I don't know what it's written in. Might be C++, might be C#.
It's C#.
It's C#. So it's a managed memory model to boot, which is its own, set of worms of just understanding, like, can I optimize this with a different memory model? Can I, are we going to blame the code or are we going to blame the deployment? Like, what are the things that can fix this?
It's also image processing. So there are libraries that could be potentially running C++ behind their
under the hood.
shiny.NET API framework.
Yeah, just because I gave you an API doesn't mean the code behind it is beautiful.
And, how true.
Well, and I bet you had a room with a bunch of folks saying, if we'd written this Ruby on Rails, we wouldn't have this problem. It could all be done in Python, it'd be fine. But you've also got the guy going, I've always hated that API. Like, we should be using this one instead. And like, the interesting thing about any of those answers is now you ignore the problem while you re-engineer rather than actually address the problem, which is can we infrastructure our way out of this rather than go back into the code for it.
And I think that's one of the biggest shifts for developers when it comes to cloud native is not all problems need to be solved in code.
Are not best served by code. Like your code is good enough and the incremental optimization won't save us.
I don't think there is a developer around who understands the concept of good enough because all code must be perfect.
Yeah.
And I think the hardest lesson as a developer is the day that you realize that perfect code is not commercially viable.
Yes. No software is finished, only abandoned, or rather kidnapped from you.
Right.
It's no, we're going to deploy this now. You don't get to change it anymore.
Yeah.
But I appreciate that it sounds like a bunch of your dev team is directly involved in the infrastructure responsibilities too.
And so we try to keep it as part of the same team.
Mm-hmm.
So because they are so intertwined and because there is so much information that we get from the infrastructure that things are running on, then it just doesn't really make sense to separate them too much.
Well, and as soon as you describe a pipeline dashboard, I know there's devs caring about infrastructure because it's the only way that thing exists is that somebody realizes we don't have enough visibility in this problem. I can write some code to give us visibility. Normally, ops folks don't count on those because they can't make them. But as soon as I have a dev senior enough to start understanding we're not knowing how the interplay of these services are working, I can write code for this. You get with these clever dashboards. And
we actually have two different kinds of dashboards. So
really?
We have dashboards for operations. So 24/7 support, monitoring dashboards of real time.
Right.
And we have separate dashboards built on the same technology that are specific for development and testing.
And load testing.
So we make our dashboards for our purposes and operations makes their dashboards for their purposes.
Nice. Yeah, that's good to see. And so there's got to be some interplay in there too. It's like we're having this problem in production. Let's go back to testing and see if we can recreate it and what visibility we get with our, I would probably more detailed dashboards for certain aspects.
I think one of the biggest differences is actually that operations is almost always looking at a much shorter, more recent time frame because they want to know what the system is doing now.
Right.
Whereas the information that we need isn't necessarily what is the system doing now because it's very hard to analyze a problem looking at one point in time.
Right.
We need to see what does it normally look like?
Right.
So give me,
has changed?
2 days worth of data and let me see what the difference when the system was working compared to when the system stopped working the way we expected.
When the Olympics opened and everything changed. Yeah. Well, I mean, you literally have examples of your worst case load tests in those kinds of events. It's like, this is the shape of dangerous, difficult workloads. How are we going to get good at managing those?
But at the same time, our load tests struggle a little bit because it's very, very hard to accurately simulate that.
Hugely
because the thing is that, okay, the Olympics opens, but even if they have, an official start date of an event, there's still kind of that soft lead up where there's things that are happening and the traffic is increasing.
Yeah.
So a spike, in air quotes, isn't necessarily a cliff.
No.
It's just a very steep increase.
More, and a little more, and a little more.
With a lot of load testing, it becomes actually a cliff. So we went from 0 to 60 in 0 seconds. And that's not actually a realistic scenario.
Yeah.
So sometimes you have to either adjust the tests, but that can be very, very difficult to actually simulate that level of scale up at the right rate.
Yeah. Especially when you're talking about memory managed code like that. Like I certainly ran into this problem doing load tests on websites where if the site's been running for more than 24 hours, the garbage collected generation models are mature. They have a good, the garbage collector learns what kind of workloads it's doing. And if you literally have just turned that server on and then you throw a load test at it, you are seeing something that is nowhere near what production is going to be like for how garbage collection is going to work. You have to run a low-level load for a day to actually have all the generations having iterated and the memory model sort of be set before now I ramp my load up and start to see really where things are tipping over. I just summarized like 3 months of banging our heads against the wall.
Yeah.
Like, why is our load test passing and our production tests and our production environment not?
Yep.
It's because we had created fake tests. We created tests that just didn't look like what production was going to look like.
I think the memory issue is actually one of the hardest to analyze because you're never entirely sure whether it's just garbage collection hasn't kicked in yet,
right,
or whether the memory is actually becoming a problem.
Yeah,
right.
So I think in those cases, it's almost impossible to test it in a short time frame because you need to give it enough time to correct itself.
And you have this non-deterministic aspect, right? You never know how big the images are. You're never going to know when did the Gen 2 garbage collect kick in? Like, those are all subtleties, and they're not reproducible. Even in a given load test, I think they're basically not reproducible, much less, users are way weirder than load tests. They do stuff.
Can you log that stuff? And if you can, how do you interpret those logs? Like, can you log when the garbage collector happens? And can you know?
You can.
What,
yeah.
I think your second question there is the more interesting one. Is even if you are logging it, how do you actually turn that raw data into something that you can actually analyze?
Yeah.
Because you could probably put an entire developer, a full developer day just on trying to actually do the data analysis and build a system that can transfer that raw information into something that makes sense and can be consumed by humans.
Yeah. Can you get to a place where you feel like it's when this particular garbage collection happens that we have this set of problems?
Right.
And recognizing also you have many instances. Every one of them is going to be a little different. A bunch of them are going to get killed and recreated anyway. So, what does that look like?
Reminds me of a problem I recently had just yesterday. Do you remember how my laptop was just crashing?
Yeah, spectacularly.
Like, so at one point, I just saw this pattern of gray patchwork on going.
Like it looked like a hardware failure. It
really looked like a hardware failure. And I found out that it was a wireless mouse. Now, there's no way that I could have figured that out by looking at the application logs.
Right.
And the system log didn't tell me anything. It was running, then it wasn't running. I got logs after it booted up, but not when it shut down. And so I didn't the only way I could figure out it was by, what do I have plugged in here? Oh, I have a wireless mouse. Well, let me get a regular mouse and plug it in. Sure enough, that's what it was.
Empirical data.
Yeah, empirical data. But it's really hard, really hard to do that in a complex system like we're talking about with so many services.
You may or may not really know if it fixed it. All you know is the problem went away.
Well,
at least for now.
That's true.
Yeah.
But I had the same problem on a different laptop with that same mouse.
Right.
So that tells me.
Just a bad driver.
Yeah, or something. So I'm not going to be.
It's one of the things I think we do have the advantage in the cloud. It's like you can't ever blame the hardware now.
Yep.
Because you don't know what hardware you're actually using.
Well, you could still blame it, but you might be wrong. If it makes you feel better, go ahead.
Yeah. But you certainly can blame the configuration. I have selected the wrong hardware to run this on. No?
Yeah.
I have no comment on that.
Yeah? Have you not had that, like, we're looking at the different service configurations saying, does this behave differently in a different one?
The thing is that even though there are different service tiers, you still don't necessarily know what is behind the scenes.
Right.
So, yes, they can tell you that you're getting the equivalent of X memory and X CPU, but are you actually getting...
Yeah. Do you really know?
Are you running on a piece of hardware that has those specs? Probably not, because
it's probably bigger than
most
that.
of the time it's not viable space-wise to put those low specs into an actual server farm. So
you're running a subset of a piece of hardware, actually. Well, and they're now offering more and more of them. Like, in some ways, it's like, well, which one do you want to pick? Now they're offering AMD sets and they're offering GPU sets and they're even starting to offer ARM servers now. It's like, is this a good idea? Like, what difference will this make?
But of course, the hardware still kind of comes into play because things still go wrong behind the scenes.
Yeah.
And when the hardware has issues, because it is a physical system.
Yeah, and it will break. But I would think that's very unrepeatable. Like, if I've got a repeatable problem, that's probably a configuration issue. And if I've decided it's the hardware, the chances of us detecting a problem in the architecture of Azure is remote. I'm going to blame my stuff first.
Right.
It's usually the best option.
Yeah.
Occam's razor.
Yeah. It's like, it's probably not them. It's probably you.
Exactly.
That's okay.
Well, it's probably not the hardware.
Yeah.
But the thing is that it could be the hardware, and it could be the infrastructure running on top of the hardware, and it could be something you were talking about N-tier architecture. Now we're at like N-tier
infrastructure. Yeah.
Exactly.
Yeah.
So
did you call PSS, like tech support for Azure at some point?
We have.
Yeah. Like, and has that been beneficial? Like
sometimes. So no, we've had some really good experiences, but right now we actually have an open Azure ticket where we lost some of our monitoring data.
Oh,
and at the end of the day, we aren't entirely sure what happened. It's back now. We don't think it's going to happen again.
That was their answer. So that sure sounds like, we screwed up. Sorry. Mm-hmm.
We pushed them for a little bit more detail. We haven't gotten it. So either they legitimately don't know, or they have been told by their customer support filter
that's as much as you can say.
They aren't allowed to tell us.
Yeah, that's as much as you're allowed to say. And in the end, if it's really not going to happen again, then that's great.
And luckily, we have multiple test environments. So that particular piece of information that we lost, it happened at the same time that we were actually upgrading our AppService environment.
Oh.
And so it very much seemed like they were related.
Yeah.
And so we said, we can't do this in our production system if this is going to happen.
Right. Can you give us some confidence it won't happen again?
Exactly. So thankfully, we have another environment that we could test with. So we did the migration again on a different environment, and we didn't see the problem. So I am a little bit, much more willing to trust their answer of, no, it's not going to happen again.
Not going to happen again. Yeah, that's great. And this is the other power of the cloud, right? Is I don't have to wait to buy new hardware to try another test infrastructure. You just harness a bunch more of their gear and run it again and see what happens. So,
have you, Richard, ever used any of the GPU SKUs?
I haven't had the workload. But, I mean, I'm fascinated when we talk about video, photo manipulation and previews and so forth. Like, isn't that well suited to those GPU engines?
But you also have to build the code around.
Yeah, do you know how to code
them?
that? Right, it's a different way of programming. So now I need those lower level skill sets. Am I really going to get the benefit from it? Because you're going to probably that first chunk of code written for GPU is going to be like that first clutch in your car. You're not going to get very far, and you're going to make some bad smells.
Well, I actually used a VM, a virtual machine that had a GPU, and I used that because I ran a streaming app, vMix, in the cloud. One of the biggest things when you're doing live streaming is if your computer decides to crash, everything
breaks.
Everything breaks. Yeah. Like it's not easy to recover from. So I was being paid a handsome amount of money to do a live stream for, hundreds of people.
Right.
And I decided, you know what? I'm going to put this in the cloud.
Yeah.
I'm going to
offload
turn it up, run it, shut it down, delete it, and there you go.
Pay the bill at the end of the month.
And it was really worth it. But I had to use an Azure VM that had a GPU, and it did the job, man.
Yeah, made a difference. So, but I think it's fascinating. I mean, certainly you have that option to you now with all these different instances, and you've peeled off the CPU beast. It's like, is it worth us maybe looking at that API and say, will it take advantage of GPU features? Can we run it against that? And, does it make a difference?
Significantly more expensive, I would say.
But not as expensive as having to build the hardware yourself.
Well, certainly not as expensive as failing.
Yeah, there's that. But then it's also a trade of, is it sufficient performance? Do we want to mess with it more versus maybe it would be cheaper if we're using GPU well? Like, it's an all interesting conversation.
And it's always the issue of pragmatism.
Yeah. So I actually have 50 other things on this list. This one's more or less solved. Can we move on?
Exactly. So someday, and that's one of basically the answer is, okay, we'll put that on the backlog to look into it.
That 50 list? It's 51. You've probably got bigger fires to fight. Although people do fall in love with problems. Like if you've been fighting that problem for X many weeks, you've gotten to a certain place, you're now in love with that problem.
Well, it's more like unwilling to let go of the problem. Like unwilling to admit that it's no longer a problem.
Yeah, it's haunting me in the shower. I keep, getting out drying off with a new idea of how to do better.
Mm-hmm.
And I think this is one of the hardest things about kind of the project management side of things is saying, okay, yes, well, we have good enough.
Yeah, sufficiently solved. Thanks. Let's move on.
So what's in your inbox? What's next for you?
On what scale?
Oh, you pick one.
So we have gone live with our first commercial customer on the new system that I have been helping build.
Congratulations.
Yeah,
So
congrats.
now the next step is to go back and change all of the decisions that we had to make along the way and take a step up from good enough to
2.0.
slightly better.
Yeah. Or 1.1.
So we are shifting away from AppService plans for the scaling of the system and moving over to AKS.
Right.
So that we have that fine-grained control. We are looking at bringing Elasticsearch in for doing our indexing for us.
Nice.
So we'll probably, at some point 52 on the backlog, I think we're up to now, maybe have some kind of hybrid between Azure Search and Elasticsearch so that we can take advantage of the cognitive powers of Azure Search.
Right.
And then basically use Elastic on its own without the Azure wrapper for kind of the workhorse boilerplate.
Cool.
So we are making those changes now, and the plan is to bring on the next big customers starting next year.
Yeah.
So we have the infrastructure in place, literally and figuratively.
So I take it it's going to be a busy week, busy few weeks, months, years, whatever. You're not bored.
Is anybody ever bored in this industry?
There's no excuse.
Yes.
For boredom, right?
When you get bored, it's time to change.
Yeah.
I would also argue, look at the list you just spat out. You really want to gnaw on the CPU beast problem anymore? Because there's some cool stuff to do.
That's right.
Let's go work on the next problem. It'll be fun.
Well, Meg Gotshall, thank you very much for joining us today. And we learned a lot.
Thank you.
All right. And we'll talk to you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got a transmitter banned by the FCC. Yes, I'm a